All right, so example 1 says sketch the graph of the function y equals 3 cosine the quantity 2x minus pi over 2 plus 1. So the amplitude is 3. The period would be 2 pi divided by 2, which is pi. Now the way that this is written, the phase shift is going to be pi over 2 divided by 2. So remember, we have two different forms that your trig functions can come in. So this is that other form, and it's a positive, so it means it's going to be to the right, pi over 4. And this is a vertical shift of up 1. So what I do is I'm going to do my mapping notation. Do 2x minus pi over 2 equals your dummy variable. And then when I divide by 2, that does become pi over 4 there. So I'm going to take x comma y, and it's going to go to x over 2 plus pi over 4 comma 3y plus 1. I'm going to start with my parent graph of y equals cosine x. The parent function is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Where does cosine start for the parent function? 0 comma what? 1. Okay, so it goes 1, 0, negative 1, 0, 1. And I do need to let you know, like, trig's not going away. We're going to spend a good 3 or 4 more weeks on trig. So then I'm going to filter this through my mapping notation. And so when I plug in 0, I get pi over 4. And when I plug in 1, I get 4. So I went ahead and did this already. So I got pi over 2 comma 1. 3 pi over 4, negative 2, pi was 1, and I got 5 pi over 4 comma 4. So this is going to be important when we're done. So I'm going to make my ticks go pi over 4s. So here's pi over 4, 4. Pi over 2 is 1. Then I went down to negative 2. Okay, in the parent function is it? Yeah, no, but I've in my mapping now. Then it would be helpful if you keep going. Oops, sorry, should be a little more rounded there. All right, now, because of where we're headed, I want to ask you a question. 4 is clearly the maximum, and negative 2 is your minimum. So I want to look at two different things here. From the maximum to the minimum, look at the x values. I went pi over 4 to 3 pi over 4. From the maximum to the minimum, what is the distance on the x-axis from the maximum to the minimum? Pi over 2. Now, isn't that half of the period? This is going to be really important because I'm going to flip the tables on you in this section where I'm going to oftentimes give you a graph and ask you to come up with the equation, or I'm going to give you data values or other information. And one of the things I need you to understand is from the maximum to the minimum, that x distance is half the period. Now, let's also look at your y values. From negative 2 to 4 is what distance? 6. And what's halfway? 3. Isn't that the amplitude? Okay, that's going to be important. All right, so, and again, example 1, example 2 is complete review. This isn't any, we're not even to any of the, and even what example 3 is still, it's to me truly not new. Example 2 says write a function whose graph will have the given characteristics. So I do want a parent function of y equals sine x. So I'm going to give you a head start on me. Try to take all the information that you have and come up with the equation. So my parent is y equals sine x, and my general form is y equals a sine b, the quantity x minus c plus d. So my vertical shift, that's going to give me the d value. I see nothing here about a reflection over the x-axis, so then my amplitude is the a value. The phase shift is going to be the c. And I only have to do really only one extra thing when I have the period. For sine, 2 pi over b is going to equal pi over 2. And if you're struggling, you could just cross multiply and say 4 pi equals pi b. So b is 4. So here we go. I'm just going to plug everything in. Y equals 4 sine, for the quantity, x minus pi, plus 3. Okay, you guys remember that? Yeah.
Do you want it written like that most of the time, or like 4 sine times 4x minus 4 pi?
It does not matter. Either way is fine. Not one way isn't better than the other. All right, so given a situation, and that's a typo, from the real world, in which something varies sinusoidally, derive an equation and use it as a mathematical model to make predictions and reach conclusions about the real world. So if you've ever seen in the Columbus Dispatch, usually on January 2nd, on the back of the metro section where they keep the weather, they plot the entire 365 days of weather, and it's a sine curve. It's really cool. So watch what we're going to do. There are lots and lots of problems that can be described sinusoidally. And sinusoidally is sine or cosine, whichever best fits it. So it says, suppose that the water wheel in the figure at the right rotates 6 revolutions per minute. You start your stopwatch. 2 seconds later, point P on the rim of the wheel is at its greatest height. You are to model the distance d of point P from the surface of the water in terms of the number of seconds t the stopwatch reads. Assuming that d varies sinusoidally with t, you can sketch a graph of the function. Then use your mathematical model to find the time when the point P first emerges from below the water. So I want us to stop and just sort of take in the picture. Do you see that I have a circle? Okay, the water wheel would be a circle. And from the center to the edge, my radius is 7, okay? But do you see from here to here is only 6 feet. So what does that mean right here?
1 foot of water.
Yeah, you're 1 foot into the water, right? Or below, like the surface. So here's the interesting part. So if I think about time and then the distance, after 2 seconds, it's at its maximum height. All right, so now think about this a moment. From here, which is 1 foot, okay, that's 1 foot up. So what is the maximum height? It's not 14.
13.
It's 13, right? It's actually 13.
13.
And then, so this is going to be the maximum. And then, okay, let's stop and think here. It says the figure at the right rotates 6 revolutions in 1 minute. So it would do 1 revolution in how many seconds? 10 seconds, right? Because you're really doing 6 revolutions in 60 seconds. So you can divide both by 6 to give you that you do 1 revolution in 10 seconds. Now, here's like the method to my madness. When I was talking to you on example 1, and I said, look at that distance from the maximum to the minimum, and it's half the period length. So really, if you think about it, the period length then is 10 seconds. So how many seconds later am I going to have my minimum? 5 seconds later. So at 7 seconds, now this is a water wheel, so it does go under the water, okay? So as it's rotating, to get to the minimum, that minimum is actually at -1. It's 1 foot underneath the surface. And then if it takes 10 seconds to rotate the whole way through, at 12 seconds, it's going to be back up to the maximum. So let me pause a moment and get you to think about this, okay? Because really, I love this stuff. This is really, really fun because you've got to stop and think. It's not as explicit as what we were doing before. So, okay, it says after 2 seconds, you're at the maximum. So it was 6 feet to 7. You hit the minimum, which is, we can see on the diagram, it's going to be 1 foot below. So that's -1. I know that to do 1 revolution is 10 seconds. So I did 5 and then 5 more. So watch this. This is cool. So let's make a grid. So I've got time on the x-axis, and I'm going to do distance on the y-axis. On the x-axis, I have room to go by 1s, but how I sketched this, I didn't have enough room to go by 1s on my y-axis. So I'm going to just adjust it to going by 2s. So let's graph it. So I want to reread the problem. It said, assuming that D varies sinusoidally with T, you can sketch a graph. Then we're going to find a model. And then we're going to find the time when the point P first emerges from the water below. So that's going to be a cool problem to look at. So here we go. Here's 2, 13. Here's 7, -1. And 12, 13. So here's the graph. So now you'll be able to see like why I had you do example 1 and why I had you do example 2. I wanted to make sure we brought everything back and we could look at the graphs and how the graph and the equation tie together, as well as in example 2, when you know the period length, how do you find the piece that you need for the equation? So if the period is 10 seconds, I know that 2 pi divided by b is 10. So if we want to write the equation, we need A, B, C, and D. Okay, we're going to need all 4 letters, and we know how to do this. So this is going to give me 2 pi equals 10b, and if I divide by 10, b is pi over 5. All right, so what's halfway from 13 to -1? Where is that on the graph? That's 14 units, but it's not at 7, right? Where is it? Because if I cross it, so that's actually my D value, right? And then my A value, so let's make another. Do you see that I've got a phase shift, or a C value is right 2, And then what trig function starts at the hill? See, you're going to have to figure out whether you want to use sine or cosine. Cosine, it would be better to use cosine. It's not wrong to use sine, and then you're going to have a bigger phase shift than what we have. But since it's starting up at the hill, my A is positive, and A is that distance from the horizontal axis either to your maximum or your minimum. So what's A? 7. All right, so I've got A, B, C. Oh, I've got it. Hey, we have everything. So here we go. This is y equals 7 cosine. I'll have pi over 5 times the quantity x minus 2 plus 6. Okay, so I've graphed it. I have my model. Now the third thing it asked me, and this is the really cool connection to what we've been doing, it says find the time, so that's the t value, when this first emerges from below the water. So do you understand it's not this first one, but it's the second one, correct? Because I want it to be emerged. So here it's going underneath the water, and then this point is where it's emerging from under the water. Well, let's stop and think about what we've been doing. Isn't these 2 points are the x-intercepts, right? They're where y, or in our case d, is 0. Watch this beautiful stuff. This is 0 equals 7 cosine pi over 5 times the quantity x minus 2 plus 6. And guess what? We did this. We did this in the last chapter. So I'm going to let you equal this horrible stuff inside. Remember, we did u substitutions. So I'm going to solve 0 equals 7 cosine u plus 6. And you're going to need a calculator. So if you don't have your calculators out, let's find it. So I realize that you guys don't always know where we're headed and why we do what we do, but like I do. So, I do need you to trust me that why I have you learn certain things is because we need it. So watch this. I would start by subtracting 6 and divide by 7. Now, I'm going to do inverse cosine here, but this is an equation, okay? So you've got to know more than the calculator. Let me say that again. You know more than your calculator. If I have negative 6 over 7 equals cosine u, all students take calculus. There are 2 quadrants. Okay, I should have 2 quadrant answers. So when I first do inverse cosine, I got 2.6. But that's not the only value for u. If I think about 2.6, that's in the second quadrant. Okay, so now do you see the beauty? See the beauty of what we learned? So you can't say, oh, I didn't learn that last chapter. Okay, now we've really got to figure it out because we're going to be using this. So watch, to get the third quadrant value, I've got to take pi minus 2.6, and that's theta prime. Then I'm going to add that to pi, to the value of pi. It sounds like 2 pi, but I meant to the value of pi. So I'm going to take pi plus theta prime, and I got about 3.68. You guys getting that? Okay. This was just a little. Let me talk you through it one more time, okay, in case you're like, oh, I'm still fuzzy with this. When I'm down to cosine u equals negative 6 over 7, I need to stop and think. Cosine of an angle is negative in the second and the third quadrant. So I do use my calculator and do inverse cosine negative 6 over 7. And that gives me 2.6. But that's not the only possibility from 0 to 2 pi. It's got to be in the third quadrant as well. So you take pi minus 2.6, that's theta prime, add it to pi, I got 3.68. So now, let's back substitute. What was u? U was pi, oh wait, I'm not ready for that, sorry. Let me do one more thing. Okay, so now, because I'm going to have to back substitute, I just caught myself. This is, in the second quadrant, it's going to be plus 2 pi k, and this one is 3.68 plus 2 pi k. I need to know what it is in general because I'm going to be subtracting, dividing, and all this stuff. So now we're going to back substitute. This is pi, and you know what? Jimmy had asked earlier, I'm going to go ahead and distribute because I think that might make the next part easier. So that would be pi over 5x minus 2 pi over 5 equals 2.6 plus 2 pi k. I'll go back and do it with the other half, but for now, this is what I've got. So do you understand what you're going to do is you're going to add 2 pi over 5 and then divide by pi over 5 to everywhere. I don't know if I didn't show all of it, but let me grab my calculator too. So I'm going to go ahead and do this in decimals, okay? So, and you're only adding like terms. So I'm going to take my 2.6 and just press plus 2 pi divided by 5, and are you getting about 3.86 plus your 2 pi k? And then I'm going to take that and I'm going to divide by pi divided by 5, and that's 6.14. Now what happens when you divide, you're dividing everything. So I have to take the 2 pi k, and when I divide by pi over 5, that's the same as multiplying by 5 over 5. So that's what, 10k? So, of course, if I let k be 0, that's 6.14. Boy, that's just right before, well, that's 6.14 seconds. And one cycle is from 2 to 12. So if I add 10, I'm beyond that. So that's, and do you notice that's the one going in under the water? Then when I go to do this other one, so that's why, like, if you didn't do the other piece, you're not going to get the other x-intercept, okay? So when I did the other one, so I set pi over 5x minus 2 pi over 5 equal to 3.68 plus 2 pi k. When I did all that, I got 7.86. And I'll leave that to you to actually do it. So then if I reread the problem, it says find the time when the point P first emerges from below the water. It's this one, 7.86 seconds.